So why do we care? Why do we even bother creating the unit circle? Okay, so it can be really useful in certain ways. Remember SOHCAHTOA and how that can be rewritten as Sir Kixer Tykes if you put the triangles in the xy coordinate plane? Well, remember in a unit circle, the radius is equal to 1. So everywhere you see r, you're just going to get 1. That means sine theta is really just y over 1, because your radius is 1. Cosine theta is x over 1. And tangent theta would still stay as y over x. So sine theta in a unit circle is just the y coordinate. Cosine theta in a unit circle is just the x coordinate. This means that if you wanted to find sine theta or cosine theta of a specific angle, you just need to read off the y coordinate or the x coordinate. So let's say, for example, I wanted to find sine of 3 pi over 4. So if I have my unit circle already filled out, and I'll have a separate video on how to quickly fill out the unit circle, right? Because it's really just quadrant 1. If you can fill out quadrant 1, the other quadrants, right, you can fill out pretty easily since they're all reflections. So for sine of 3 pi over 4, you go to 3 pi over 4, and you look at the y coordinate since it's sine, right? Sine is the y coordinate. So at theta equals 3 pi over 4, what is the y coordinate? It's positive root 2 over 2. So your answer is positive root 2 over 2. Okay, how about cosine of 11 pi over 6? How would we do this? So for cosine of 11 pi over 6, right? To find cosine theta, we look at the x coordinate. So we go to 11 pi over 6, which I find right here, and we look at the x coordinate since this is cosine. Therefore, the answer is square root of 3 over 2, right? Cosine of 11 pi over 6 is equal to root 3 over 2. So how would we find tangent of 4 pi over 3? So tangent of 4 pi over 3, right? Tangent is y over x. So I go to 4 pi over 3, and I have to do y divided by x. So that's y divided by x. So that's negative root 3 over 2 times the reciprocal, giving us, right, negative times negative is positive, positive root 3 as my final answer. So if you're using the unit circle to evaluate functions, let me give you a little tip. You could always do y over x, and notice that, right, the 2's are going to cancel out. Here's a quick way to do it. You go to 4 pi over 3, and then you look at the numerator of the y and put it over the numerator of the x. So it's really just negative root 3 over negative 1, giving you positive root 3, because I know the 2's are going to cancel out. So if I were personally using the unit circle to evaluate functions, here's what I would do. I would create the first quadrant. So I know I can figure out this first quadrant here, where it's 30, 45, 60, right? Pi over 6, pi over 4, pi over 3, and I know I can get the xy coordinates of, it's going to look like this. Everything's over 2. And in the numerator, I'm going to have 1, 2, 3, 1, 2, 3 in the shape of a U. And it's going to be all over square root of 1. So I have 1, 2, 3, 1, 2, 3, and I'm going to put square roots, but square root of 1 is just 1, so I'm not going to write that there. So square root of 2, square root of 2, again, square root of 1 is just 1. So I filled out my xy coordinates. So at 30 degrees, right, I have root 3 over 2, comma 1/2. 45 degrees, I have root 2 over 2, root 2 over 2. At 60 degrees, I have 1/2, comma root 3 over 2. So again, once you have that quadrant 1 filled out, you can find the other points as needed. So for example, for sine of 4 pi over 3, I know I'm going to have 4 pi over 3 in quadrant 3 here, and it's going to have to do with the pi over 3 point. So it's going to have the point 1/2, negative 1/2, comma negative root 3 over 2, since it's quadrant 3 where it's negative, negative. And I'm looking for the sine coordinate. So remember in a unit circle, right, the xy coordinates are equal to, right, cosine is Kixer, so cosine theta, and y is equal to Sir, right, so it's sine theta. So I just need to read off the y coordinate, and that is my answer. Sine of 4 pi over 3 is equal to negative root 3 over 2. Here's an example. Find the point xy on the unit circle that corresponds to theta equals 5 pi over 6. Just a heads up that our book likes to use like t equals 5 pi over 6, right? But it's the same thing. It's just some angle along the unit circle. So if you have a unit circle filled out, you would just go to 5 pi over 6, and you look at the xy coordinate. So you're like, oh, my answer is, right, negative root 3 over 2, comma, 1/2. That's your final answer. What if you don't want to make a unit circle and you're the person that decides to just use a left-hand trick or the special right triangles to figure out all the trig functions? Then what you would have to do is recall the following. In a unit circle where radius equals 1, right, your xy coordinate point is equivalent to cosine theta, comma, sine theta, right? Again, remember that you have Sir, Kixer, Tykes. But because the radius is 1, right, sine theta equals y, cosine theta equals x. Again, sine theta equals y, cosine theta equals x. This means if you can find cosine of 5 pi over 6 and sine of 5 pi over 6, that would give you your x and y coordinates. So you would use a left-hand trick or reference angles or the special right triangles, whatever technique you use to figure out what cosine of 5 pi over 6 and sine of 5 pi over 6 is, and write that as an ordered pair. Go ahead and try this problem here. The correct answer is root 3 over 2, comma, negative 1/2. If you have the unit circle in front of you, you just read the xy ordered pair, but if you don't, you have to find cosine 11 pi over 6, sine of 11 pi over 6, and rewrite that as an ordered pair. Let's say you have to find the exact value of sine of 11 pi over 4. How would you do this? Well, one way is to remember the little slices. Right, so right here would be 8 pi over 4, and you would go 9 pi over 4, 10 pi, 11 pi over 4. And you would use the y value of that point. Notice that it's the same as 3 pi over 4, right? It's the same location. Or you can find just sine of 3 pi over 4, right? Because 11 pi over 4 and 3 pi over 4 are coterminal angles, you're going to get the same answer. And sine of 3 pi over 4 gives you positive root 2 over 2. The other way you could figure out that sine of 11 pi over 4 is equivalent to sine of 3 pi over 4, because that's easier for us to do, is just to find the coterminal angle of 11 pi over 4. So recall that you can find coterminal angles by adding or subtracting multiples of 360 degrees or 2 pi radians. So if I have 11 pi over 4, I can subtract 2 pi, right, which is 11 pi over 4 minus 8 pi over 4, giving me 3 pi over 4. So I would say, oh, sine of 11 pi over 4 is going to give me the same thing as sine of 3 pi over 4 because they're coterminal, and then you would find your answer that way. Whether you add or subtract multiples of 360 or 2 pi depends on the number that you have. Go ahead and try this problem. Evaluate cosine of negative 20 pi over 3. So I notice here that negative 20 pi over 3 is a very negative angle, so I'm going to add 2 pi's to it. So I'm going to add multiples of 6 pi over 3 to it. So notice if I add 6 pi over 3, that's still going to be negative, right? It's like negative 14 pi over 3. So you can add however many multiples of 6 pi over 3 you want. So I'm like 6 times 2 gives me 12 pi. That's still, right, negative 14 plus 12 pi is going to give me a negative number. So I'm going to do 18 pi over 3. Do you see that? Because 18 pi over 3 is 6 pi, which is like 2 pi 3 times, which would give me 4 pi over 3. Or you could just keep adding 2 pi's, right, or 6 pi over 3 until you get a angle that you're comfortable with. So really, cosine of negative 20 pi over 3 is equivalent to finding cosine of 4 pi over 3. Cosine of 4 pi over 3, well, 4 pi over 3 is in quadrant 3, so therefore cosine will be negative. And cosine of pi over 3, or 60 degrees, is 1/2, so my answer is negative 1 over 2.